Hello and welcome to another episode of the Oxford MAT Livestream. My name's James and today we're talking about the 2015 and 2016 MAT past papers. But first, public service announcement. Do you know where you're going to sit this test? Assuming that you're going to sit this test this year. Sorry if I panicked you. If you're not doing my test, then I mean fine, ignore this. But if you are doing the test, you need to take it in a place. You might already know that you're going to take it in your school or college. You might like to check that they know that as well. We've got a couple of weeks for test centres to register candidates, and I just want to make sure that everyone's, communicating, making sure that stuff's all linked up. There's a website if you're not sure where you're going to take the test. There's this concept of open test centres. I've heard that you can go to that website and try and find one. So good luck with finding somewhere to do the test if this is the first time you're thinking about it. Okay, public service announcement over. Let's do the how was your day poll. So I've got chat going as well. Where is my how's your day poll? There it is. Hi to S in chat and some anonymous people. I've been chatting to people in chat before we went live about things like Singapore A-levels and gap years, and we said they're coming to the open day, so I will see them tomorrow. At time of recording, it is Thursday at 5 PM, and there's not many hours left until the open day, where I'm doing the kind of maths at Oxford intro talk. And people are not by default bringing their own computers to the MAT. So there's the question in chat says, if people are bringing their own computers to MAT this year, how is cheating prevented? My understanding is that that's not what people are doing. Inside, outside. Hi Tara. Tara in chat, very quickly. Tara in chat says that they've just got 4 A stars. Congratulations, Tara. That's brilliant. Well done. That's amazing. I wonder if that means Tara's off to university or see you around. I've sometimes thought about doing, this is brilliant. Tara's got a thumbs up from somebody else. Chat's lovely. I've sometimes thought about doing like content that's helpful for people at university, because we've now got quite a few people who found this helpful and are at university, and then I don't make anything for them afterwards. So I don't know. Yeah, good job. Oh, an Open Centre told you they're doing bring your own device. I need to look into this. I'm sure someone other than me knows what's going on. Contrary to what I say sometimes, I'm not in charge of everything, and I'm not in charge of the kind of physical aspects of test delivery, just the kind of maths. Right, good. Okay, that trailed off awkwardly. Average score is 4.2 on the how was your day, with loads of people voting 5 stars, more than 50%. I can feel the energy in the room. People are having a good day. Hi to Dresden Herb in chat as well. It is good to be live. I've just been in the middle of a kind of 2-week bridging programs, or sort of summer school, except it's not really summer anymore, is it? Sort of 2-week summer school that we do for a small number of people just before university, just before the Oxford MAT course starts. We invite a small number of people to kind of pre-course, not a foundation year, like a foundation 2 weeks. It's not really called that. It's called Opportunity Oxford. It's really good fun, and that's what I've been doing for the last 2 weeks. So I have no idea. Okay, right. So new question. Let's just be honest. Question in chat: are allowed to bring our own devices to MAT? I have no idea at time of recording. I just told someone no, and then they told me yes. So now I don't know what to think. Don't ask me. Please talk to your test centre about how the test is going to work. And if they want to know, they can talk to someone at Oxford who knows. There's a place on the website where you can find test centres in your area. They're not all listed yet. They're adding more. The place you go, it's slightly counterintuitive. I've spoken to someone about this. Apply for authorisation to run Oxford's admissions test. And I think there's also a different route in, but the route I know in is you pretend to be a test centre briefly. There's a button for become a test centre or a button for find a test centre. But once again, sorry, the button I hit there is apply for authorisation. Find a test centre, and then find your test centre. I think that's the search thing that someone in chat's looking for. Hi, Nai. So someone says, why can't we use paper nowadays? Good news, in 2023, the year we're currently in, you are using paper. You're going to write your answers on paper. Do I need to do the MAT information again? I kind of don't really want to do the MAT information again, but going to see the questions on the computer screen. We're going to answer on paper. Your paper's going to get scanned. My team of graduates are going to mark your paper after being scanned. Tara would like solutions to an extra 10 years of math papers, which I don't think I do. Yeah, I think the answer is just no. I mean, solutions probably exist like vaguely out there, but I've looked through my computer, the files I was handed over, and I think the answer might just be no. Yeah, Dress says, please, if you want to get your school to register as a test centre, that is something that you should do basically now. A Year 12 student in chat wants to take math for fun, which is sadly not allowed. Math's not an open examination, you just take it if you need to. Is there a way to try an online version of the math? Yes, let's try and find that. So same website. This website contains loads of things, right? So where do we go? We try and find the mat. We try and find information about the mat. How do I find information about the mat? Yeah, okay, I guess I could hit maths. Let's try and find it. Yeah, okay. There is, how do I test preparation and practice materials? There's a video, there's an online test. Right, okay, so I had to hit navigating the websites with James Monroe. I had to hit, excuse me, let me just fix that. I had to hit ox.uk/tests, and then I had to math submissions test, and then test preparation practice materials. Scroll down, practice online. There's an online thing. Okay. Top question at the moment. Did Oxford used to pay a lot of money to Cambridge, which is why they stopped? I don't think I'm allowed to discuss that. Good. Right. Why isn't Matt an opening examination? So it costs quite a bit to mark because we mark it really carefully. Oxford currently takes, Oxford Imperial and Warwick between us take the cost of the marking. And we mark it very carefully, and graduate students, we pay them properly, and we don't charge that money to test takers. If it was an open examination, we'd get probably like an extra few thousand people taking it just for fun, and we'd also have to mark their scripts. 2015, did the 2015 yesterday, hooray! Okay, good, right, we're going to do some 2015 questions. I've got, is there a stream on at the moment? I think so. Live, what's my link? Hang on, I'm just helping one person. Stream from link from Matt website, oh dear. So maybe I'm not live, or maybe I am live, who knows? Maybe I'm just an illusion. There's never a James at all. Can I pay more for marking? No, we don't currently have a system for you to take the, don't have a system for you to pay me. Right, and PAT is the same system, I'm afraid. It's not an open examination. Can't do it for fun. You can do past papers for fun, and I've put, oh my goodness, so many past papers on the website. So if you want to check the website for so many past papers. And there's one on screen now, so let's just do this one for fun. Good. There's a vote on chat for which questions we should do live. On screen, I'm going to start by doing, I think, one of these questions, which I'm going to select. Or I think it's the logarithms question. I love a good logarithms question. Which means I need to do that so we can actually see. In chat right now, you can vote. I can still see the Q&A behind, but it's not on the screen. That's what I'm saying. I have still worried that I'm not live. Am I live? What does YouTube think? YouTube thinks I'm live, and my bitrate is higher than recommended. I love it when I get that error message. Yeah, reckon I'm live. I'm just going to talk about logarithms. And hey, if it was just me talking to myself about logarithms, what's new? Right, okay, this is one of those questions where it's a mix of polynomial and logarithm, two topics smashed together, and I think I like it because you have to try and undo that unholy mess of smashing together those two concepts. In particular, the fact that you're supposed to be using here is on one of the MAT flashcards. It's one of the things on the MAT syllabus. This means that a to the c is equal to b. So if you do a to the power of both sides, for example, then the left-hand side simplifies down to b, and the right-hand side is just a to the c. Ben says that I am live, so that's nice. Thank you, Ben. Okay, which in here, this stuff down here is a, this stuff in the brackets is b, and that thing over there is c, if you like to think of it like that, which means that 4 minus 5x squared minus 6x cubed is, what's a? Oh, x squared plus 2 squared, which, and now it's turned into a polynomial, and at this point you can sort of relax, if you like polynomials, I suppose. Some things cancel, there's a 4 on both sides. And I think it's going to simplify even more than that. There's no x term, so prepare for extra 6x cubed. Oh, what do I want? I want none of that. I want my terms in order. Oh, that's nasty. What was that? Oh, I know what that was. Okay, right, good. Right. We got a bit of tech weirdness, but it's going to be fine. What do I want? So I want the x cubes term next, which is 6. What you saw there was a combination of tech being weird at the same time as me being weird, which is never good. What on earth have I done? Oh, there we go. All right, I've got my 2 solutions. I should probably go back and check these by checking like log base 2 of, oh gosh, I hope that's 4. Yes, log base 2 of 4 is 2, and I should go and check the -3 one, which gives me log base 11 of, oh my goodness, is that 121? I should go and check that, I suppose, but I'm not going to check it now. I'm going to circle C and move on. It's a nice quartic, isn't it? Quartic is a polynomial with degree 4. Yeah. Recognise this from the open day, and if you're coming to the open day tomorrow, you'll recognise this question from the future. That doesn't make any sense. Which question is equivalent to 7? So instead of question 7, people are doing question 3, and just going to be fine. The online mat does count down for 2.5 hours. If you have rest breaks, so someone in chat asks about rest breaks. If you have rest breaks, talk to your test centre. That is something that's been talked about and worked out. The online practice one doesn't know if you've got rest breaks or not, right? Because it's just the same website for everyone. But I think something clever happens if you've got permission for extra time. Yeah, I did do it in the open day, and I'm doing it tomorrow in the open day as well. So I thought I'd pick it out as a question that I love talking about. Right, good. Did anybody vote for it? No. Let's have a look at the vote. Democracy. How do I look at the vote? Oh, yeah, I need to go over here and switch on with the transition. There we go. Good. Oh, there's a draw at the moment. 1G and 3. What do people? Oh, people want 1G right up, just above. And question 3. What was question 3 like in 2015? Question 3. Oh, question 3 is long and involves some approximations. And my goodness, is that? Yep. Okay. Right. I can see why that might win. 1I and J. That makes sense to me. And yeah, I think we've talked about 1J is also a question I've used for other stuff as well. 5's got some votes just for being, if you haven't seen question 5 on 2015 before, just for being quite a mess, I think. Look at all of these M's and brackets. Ugh, there's just so much stuff. And there's function things going on there. It's another recursion question, I suppose. Right, okay, I think I want to do G first because it won. Almost half the people who voted voted for G. Actually, half the people who voted for 3. So I'll do G and 3 first. We'll see how we're doing for time. At 6 o'clock, I'm going to switch over to the other paper, 2016. That's the plan. Graph transformations as a recap. Yeah, good. Please don't neglect and do question 6. Okay, maybe I'll do question 6. If you get extra time in exams normally, then you should get extra time in the mat. And you should not worry if the preview thing doesn't look like it's doing that. Good. Okay. Yeah. Okay. Here we go. So 1G. The thing to search for is access requirements or reasonable modifications. Talk to your test centre or the exams officer at your school if you're taking a test in school. I really like these. So A is here because we're asked about cos squared x equals cos squared y. And A is here because it looks like cosine, right? But the actual graph here looks nothing like cosine. I guess D is also some sort of cosines, but the other way around. The thing to imagine here, where we're given something like f of x equals f of y for some function f, is for each value that the function could take, when does it take that value? I suppose the lines on here correspond to different values. Yeah, no. No, they don't. When does, okay, so the question is, when does this function repeat its values? And we know when cos repeats values, and this is cos squared, fine. So cos squared, I need to take cosine and square it, so it comes down to 0 and then goes back up again in the interval, and then I suppose comes down again and up again before we get to 2 pi or 360 degrees. That's pi, where minus 1 squared is 1. But the idea about it repeating values is something quite familiar to you, right? You know about how often cosine repeats values, or when it does plus or minus values. It does that quite a lot. For example, we could have x equal to y. We could just be talking about the same point. Or we could be in a case like this. So I'm doing this tiny sketch up here to try and show that there are different values that could be x and y that have the same value of f. This is a little bit awkward that I've used the letter y and drawn this sketch because the sketch is, I suppose, just f of x against x. But that is awkward because I'm not really using these x and y as my coordinates, x and y. I'm imagining them, when I do this sketch, I'm just imagining x and y to be numbers. So maybe I want to think about f of a equals f of b or something. I'm rambling a little bit because I know that people find this kind of change of notation very confusing. So maybe I just want to think about when f of a is equal to f of b. For example, like this. So I've got big numbers a and b, and they've got the same value of f of x, because I've just need to be like that. And I hope you can see that I could put b in other places too. If you do this, then you realise, well, this thing goes down and up, so it repeats with period pi. So b could be a plus pi because of the periodicity of this function. That's all right, I suppose. That tells me that y equals x plus pi should be part of my line. Oh, that's part of c. So does that just mean it's c because I need to include this line here? Yeah, none of the others have got that. Easy. No, not easy. But there's lots of other cases in that picture, right? Here, this line represents the ones where x is equal to y. Those obviously work. If x and y are the same number, then cos squared x is going to be cos squared y. And I suppose this line represents the ones where x is pi more than y. And the ones going in the other way represent the following case. I'm going to zoom into my picture again and show you that b could be over. There we go. B could be over here, and that's a little bit harder to think about what the relationship between a and b is. But if you think about it a lot, you realise that these numbers add up to pi. Their average is pi over 2 in the middle, so they add up to pi. So down here I'm going to write, or I'm just sort of finishing off the reasoning to give you a bit more idea about why the picture looks like this. Or a plus b could be equal to pi. And that's a line that looks like this. Okay, and there's some more because of periodicity. Yeah, we're already going through papers, we're going fast. Yeah, so there's some cos squared, sine squared identities. If you want to try and prove this, I've said some stuff about the periodicity, and you might not believe that, right? If you don't believe me, there's some stuff with sine and cosine you can use to try and prove this, to put it back together. Yeah, I think periodicity is the right way to approach that question. Just realised that I didn't lock the board, so I'm going to quickly do that. Perfect. There we go. There we go. That was my tech problem before. Okay, time to do question 3, I think. Picked out some good questions, chat. Tara wants to know if we still get marks if our solution method is different to the one in the mark scheme, and the answer is yes, any reasonable method should get you the marks, provided you're following the instructions in the question. Up here we're talking about the long questions, right, where you're asked to do something. For example, if the question is show that statement and your strategy is to claim that the statement is true by just writing it down, then that's not really a strategy that I can give you marks for. But if it's something sort of like you want to use the sine rule instead of comparing angles with extra lines on the triangle, you want to just use the sine rule instead, or maybe the other way around, then that's fine. And we do try hard to try and think of those in advance and then add them to the mark scheme if we see them along the way. Part of the fun of marking. Yeah, good, okay. Right, question 3's been requested, and look, it's like a page and a half long, involving loads of reading. Luckily, I think some of the reading makes sense, so we're going to give that a go. Who is the principal examiner who sets mark schemes? Oh, that's easy, that's me this year. Can you work backwards on a proof by using if and only if statements from the desired conclusion and deriving something true from there? David, yes, provided that those really are if and only if statements. If you're going to do this, be careful. Check that you don't. It's easy to make mistakes. Yeah, if your method is looking at a triangle, there we go. It's a great example. Thanks, chat anonymous. If your triangle is prove that the shape is a triangle by saying look at it. Wait, hang on. That's one of those memes, right? One of those memes. Like, how do you prove it's a triangle? Prove it. I think I've seen them. I think I've seen that. Right, good. Okay. Question 3. On this episode of James Tries to Remember Memes. On this episode of the Oxford MAT Livestream, we're doing question 3 of 2015. In this question, we shall investigate. I quite like it when the questions introduce themselves. Right, okay, mod x is going to be equal to x if x is positive, minus x if x is negative. I think I've seen this before. It's like the distance from 0. With the notation, we say that f is an excellent approximation of the function g if their difference is kind of small. 320, fine, okay. Whenever we're in some particular range. I'm going to quickly sketch a doodle because I'm never going to remember that. Okay, excellent. F and G, excellent. Okay, and we say f is good approximation to function g if f and g within 1 over 100. That's good. Okay, and these are like for some reason between 0 and 1/2. Okay, so I guess they could do something else outside, but okay, fine. Maybe I'll just remind myself that I'll make a squiggly over here. I don't look like a very good approximation that I've put the squiggles on, but hey. Oh, I'm underneath the chat. Sorry, chat, I've turned you on because you were saying clever things and then chat's in the way. There we go. The thing is, I have to look at chat to realise that you've said chat is in there. Anyway, never mind. You can get marks for later questions, even if you skipped part or used the result. Good, okay, give an example of two functions f and g, so we're doing part 1, such that f is a good approximation to g, but f is not an excellent approximation to g. Right, okay, so they need to differ by, should I just make them differ by something in between? So like f of x is equal to, I am so lazy when it comes to examples, right? I just want like g of x to be like a good-ish approximation. So something between 100 and 320. Yeah, okay, that seems like f's a good approximation to g, but not excellent, because the difference is 1 over 260, which is smaller than 1 over 100, but not smaller than 1 over 320. It seems like there are many, many examples you could put for this. If your example doesn't match the one on the screen, that's fine. The one on the screen is, I don't know what came over me. Ella, or possibly Aya is, Ella is here for the first time, A-L-L-A, nice to see you. I'm gonna go Ella, it's palindrome. First time joining, recent further maths, have fun. Love further maths. Accidentally got an A, resitting it. I think that's what, given that you've got the A already, I think that's what I would encourage people to do, to try and get the A star. Sounds fun. Good, okay. What are we doing? Show that if f of x is x and g of x is x plus sine 4x squared over 400. Wait, I should make this interactive. Let me know in chat. What were your examples? Did you go for something more interesting than this? Less interesting than this? What was your pick for things that are good but not excellent? Maybe you picked exactly these functions, in which case, ooh, spooky. Right, I'm going to keep doing part 2. You tell me what you've got. Herb would be worried to put that down. That's a nice thing about mathematicians, right? If it's technically true, that's all you can ask for sometimes. Technically true is the best kind. Oh, x squared plus 1, x squared and x squared plus 1 over 200. And David says that their answer was precisely as uninteresting as this. x and x plus 1 over 101. Good, okay, so people have got functions. Okay, just quick side note here, just to check that people are, that you definitely know this, but functions don't have to change. They can be constant. No, there's no good way to say that, right? You obviously know that. Okay, but if sort of everyone feels more comfortable if their function varies. If flat function, ooh, looks a bit like a yeah. So there's x over 160. Oh, that's clever. Oh, I got clever ones in chat. Here they come. X over 160 and g of x equals 0. I've got to think now. Yeah, there's an equality on here, so you're fine. Yeah, you got. Yeah, that is just. Wait, no, that looks excellent to me. I'm worried that might be excellent. I'm worried. That is excellent. 160, I think change the number 160 at the top. X over 150. Yeah, 150 looks good to me. If the difference is the difference that matters. Yeah, okay. Oh, f of x is 0, g of x is 1 over 300. Right, cool. Give an example of find. I think no reasoning needed for this. I reckon this is 1 mark at the start of the question to get us involved. Okay. General, if it's just a small bit of question, it's just 1 mark. If it's needs some explanation, it's worth more than 1 mark. And I'm saying that because this year we're putting the number of marks on each part of the question. Right, okay, shall I do part 2? I think I'm going to do part 2. Click. Show that if f of x is x and g of x is x plus. Right, okay, so this is an example that's a little bit like some of the ones in chat, except nobody in chat put this x squared inside a sign. Why would you do that? I suppose what we need to calculate here is the size of f of x minus g of x, which is the size of, because the x is shared here, the difference is going to be the size of sine 4x squared over 400. I've thrown away a minus sign because it just doesn't matter. This thing is symmetric. I suppose that's not obvious from the definition I've been given, but it's the distance. It's fine. Okay. So this thing, I suppose the point of the question is we're going to try and bound this and say that this is less than or equal to 1 over 400 because the absolute value, the biggest that sine can be, or the smallest that sine can be, is 1 or minus 1. It can only, its maximum magnitude is 1. So it doesn't matter about the 4x squared, this thing inside is only as big as 1. 1 over 400 is less than or equal to 1 over 320. So we're all good, that is excellent. Okay, don't really understand what we're doing so far. Yeah, so Arnav in chat is asking about 2016 question, which I will get to, and I think you probably would get the marks. Are we ever required? Chat's asking questions. Let's put chat back on screen. No, it's just answer the questions. We're required to know about implications and if, only if and if, only if. I think you're required to understand those as English phrases. So there's the word if in here, which I'm hoping is not surprising anyone, right? I'm not expecting for MAT people to have experience of logic and set theory, I suppose, or this kind of like, excuse me. I think the thing is, I think you understand the concepts even if you don't feel comfortable with those words, and I think you've got other words that you can use. So I think you probably are. Right, are we guaranteed to not be penalised? The way I write questions is if we want you to explain something, we ask you to explain it. I think there are past questions which are a bit more vague, so not a guarantee for the past or the future, but the way I run this is that if we want you to explain, we ask you to explain. Right, okay, remainder of this question, so there's kind of a break here. Remainder of this question, we're going to try and find a good approximation to the exponential function, but we're not going to use any other properties of the exponential function. What do you mean, any other properties? Oh, is this a property of the exponential function? Quick check. Yeah, this is a property of the exponential function. Okay. Right, let f be this polynomial. Okay, so far we've got an h and we've got an f. We're on the page turn. I don't feel like we've done very much work yet, right? We've said that sine is less than 1 and we've read some stuff about polynomials. Show that if g is equal to, but I know f, right? Okay, so I know f, there's a page turn involved. I'm going to write out f at the top up here. X squared over 2, x cubed over 6. and g is going to be 1 plus the integral of that. Show that, then f is an excellent approximation to g. So this is f. Okay, I know that, and it appears inside this integral. So I'm being asked to do the integral 0 to x of 1 plus t squared over 2 plus t cubed over 6. Reminder once again that f of t means everywhere you see the input, write t. Here in the example we've got here f of x, a dummy variable x. It's being used to describe how the function depends on x. Okay, I can do this integral, I reckon. Oh, I reckon. What have I got? So integral from 0 to 0 x of 1 is x. Sorry, I'm going too fast. T integrates to t squared over 2, which gives me x squared over 2. Take away 0. T squared integrates to t cubed over 3, which becomes t cubed over 6 when you allow for this 2 down here, which integrates to x cubed over 6, take away 0, and the t to 3 integrates to the t to the 4 over 4, plug in the x, don't forget about the 6, take away 0 one last time, and that's the exact value. Good, okay. So that's g of x. I want more of f of x minus g of x, and I notice that almost all the terms are the same. So this is f of x minus g of x is almost all these terms appear again, except for this last one, x to the 4 over 24. How big is x to the 4? Well, I think in the question we're interested in x between 0 and 1/2. So this is less than or equal to, it's really small, right? X to the 4 is really small, it's really small compared to 1 over 2 to the 4 divided by 24. 2, 4, 8, 16. That's 1 over 16 times 24. So I guess the only thing left is that less than 1 over 320? Multiplication, not so good. Yes, I think it is. I should just multiply, right? Welcome back to the live stream where I'm trying to multiply 2-digit numbers together. Some people are really, really good at this, right? Some people are not. Live stream is a... Oh, that was bigger than 320, okay. We call that excellent in this question only. Good. How do I forget how to do a maths question? Multiple choice asking which statement implies which. Ah, right, okay. There are some tricksy things in going on. Oh, 16 times 24. Someone in chat's done this with the difference of 2 squares. That's very clever. Oh. On a game show, that would win like mystery biscuits. Good. Okay. What else are we doing? Part 4. Show that for x bigger than 0, h of x. Oh my goodness, what was h? Was h the thing that? Oh, it satisfies its own. Oh my goodness, I could have a look at both pages. This test was printed out on paper. The pages were next to each other. H of x, take away f of x equals g of x minus f of x. Wait, so both sides have got a minus f of x on, so that's fine, I suppose. And that g of x there is this. Wait, so I'm being asked to show that, and I still feel like I'm working backwards. Minus 0 to x, ht minus f of t. I've got too many minus signs. Because my line has gone right through a plus and made it look like a minus. Right, and then that's just going to be true because this f of t integral is going to cancel out. Okay, so this is an example where fiddling around with the terms in the question gets me down to a true fact, and then what I would really do if I had a minute or two is I would write this out the other way round. And everything here is reversible, it works both ways, it's just all fine, everything's just equal to each other. But I think I would rewrite it the other way around, you know, like we have h of x equals 1 plus 0 h of t to t, and then I would write out that's 1 plus the integral from 1 to 0. It's also fun doing something like this makes you feel a little bit like a wizard because you've got this stuff appearing out of nowhere. Like, who does this step, right? This step, reading top to bottom, this step says start with 1 plus an integral and then just bring in a new integral. write it on its own and inside merge together with the existing integral. Who does that? Nobody does that. Which is 1 plus, so this thing up here is g of x plus, and then this integral, which I'm going to be lazy and just put squiggle. And then, and then h of x minus f of x. G of x minus f of x, right, good. Plus that same integral. Okay. In the exam, I would not write squiggle. In the exam, I would write out what I'm trying to do. And my handwriting's got terrible down the bottom. But I hope you can see that rewriting it out that way gives it a bit more of a logical flow. Whereas this way around, I've my kind of rough working here. My rough working here is quite hard to read. Like if you weren't listening to me and you just looked at the screen, this just doesn't say anything, right? It says show that and then a bunch of maths without any explaining. If you've done right hand side equals left hand side, that's fine. A equals B implies B equals A. Mystery biscuits. I don't know why I said it. It's a line from a Tom Scott show. Tom Scott on YouTube awards people mystery biscuits if they say something clever. And I don't know, the sight of I can multiply these numbers with difference of 2 squares really, I think, deserved mystery biscuits. Doing a show that's the wrong way around and then the right way around feels like future vision, says Herb. I've been here before, I know 14,065,000 futures. And how many of them did we prove this? 1. Right, here we go. You're given that h of x minus fx has a maximum value. Well, has a maximum value, that's good. On the interval at x equals x naught. Okay, sounds good. Explain why. Oh my goodness. Oh no, explain why this is true. H of t minus f of t. This looks like the integral of the previous thing. I tend to, on the live stream, I tend to write on stuff a lot, which makes things quite messy. Explain why this integral, which looks like the integral of the left-hand side to me, is less than or equal to, and there's some stuff on the right-hand side. Oh, I don't want to integrate that twice. Wait, no, this looks exactly like that. Okay. Interesting. What have I got? Kind of want to rearrange it. I don't understand why I've got a minus f of x on both sides in part 4. Oh, I'm being given that that has a maximum at x naught. Right, okay. So I've been given that. Okay. So this thing has a maximum at x naught. So I could definitely write down that g of x minus f of x plus naught to x of h of t minus f of t dt is less than or equal to the value at x naught, h of x naught minus f of x naught. Is that useful? Not sure. In fact, what am I going to do with this g and this f over here? Chat, help. Nobody is. Who is not a Tom Scott fan? What am I doing? This reminds me a lot of university maths, in the sense that this feels a lot like analysis. What am I doing? So I've got a true fact on the board, g of x minus f of x plus the integral. Oh, that thing is less than or equal to... Right, hang on, I can bound the integral, right? Yeah, no, I'm being an idiot, right? Am I being an idiot? Yeah, it's nothing to do with the previous line. It's just because the function's not very big and we're integrating it. We're integrating it over quite a small range. We're going to small, yeah, okay. Nothing to do with this, right? It's just that the function's not too big. This thing inside the brackets is small. It's less than x. It's less than the maximum value. So minus f of x naught. And the range of integration is also kind of narrow. We're only going from naught up to at most 1/2. So that's where that 1/2 comes from. Right, okay. So the function h of x minus f of x is like some function that has a maximum value and then we're integrating over some range which is 0 to x, but x is less than 1/2. So the integral is definitely less than the area of this rectangle from 0 up to the maximum and from 0 to 1/2. Kind of big rectangle. It's less than that for two reasons. One, because the functions might not be constant, and one, because x is less than or equal to 1/2. Yeah, thank you. Yeah, it's just the area. Cool, okay. Time that I got distracted by looking at the previous thing, because I haven't yet understood why we did minus f of x on both sides. What's going on? I mean, it reminds me of a lot of analysis that I learned at university, but it definitely doesn't remind you of a lot of analysis you learned at university because you haven't learned it yet. Right. Okay. And once again, I've written all over the question. The live stream is entering a mildly chaotic period. We're going to fix that. Last part of the question. Also given that f of x is less than or equal to h of x. Okay, I think I know that that means that that's positive. I'm going to write that down before I forget it. Everything here seems to be a weak inequality with a greater than or equal to sign. Show that f is a good approximation to h. Oh, okay, pretty good, pretty good. So this tells me that I can do mod signs in different places, right? Yeah, so f is a good approximation to h means that I want to say something about h of x minus f of x to be bounded. I know it's positive, so it's okay to just check. Just check that h of x minus f of x is positive, is bounded. If it was negative, I'd have to worry about how negative it gets because the mod signs would make that into a huge positive value. Just to check that this is bounded. How am I going to prove it's bounded? Well, I still want to use the thing from part 4, right? I still want to use the thing from part 4. Am I mad? Why would I use the thing from part 4? It's got loads of terms in. Why would I even write it out as the thing inside my signs? Well, because I know how the difference between G and F works, and I know how big that is. Do I know how big that is? I know it's not too big. 1/2 of the maximum value of that function. But I didn't know the maximum value of that function, right? No. What is going on? Yeah, okay. I don't know the maximum value of that function though. Am I being daft? Sort of want to just start going at it. I'm going to clear some space and I'm going to start going for it. And chat is trying to help me, which thank you, chat. I don't think I've ever been this confused by a question, possibly because I'm writing over my own working. Okay, so I'm really considering using the triangle inequality, which I think I probably shouldn't. Let's quickly look at chat. It's a quick break to look at chat. It's not cheating, I'm just chatting. How could it ever be equal if it has a maximum? This is the constant function again, right? So I guess controversial argument, does the function f of x equals 1, does the function f of x equals 1 has a maximum, does it have a maximum at x equals 1/3? I think yes. You possibly think no. We can argue about it if you like. The triangle inequality is when you've got mod signs. You see the triangle inequality. That mod a plus b is less than or equal to mod a plus mod b. I'm trying to decide if that's worth using. I think it probably is worth using. Because I've got what I'm talking about is this mod h minus f thing, and I know that that's equal to mod g of x minus f of x plus this integral. A big part of the reason I appear to be stuck is that what I really want to write down is this step, and I'm not sure I'm going to get away with it in chat. Especially if I can't spell the letter G. There we go. By the triangle inequality, and then I have a bound on that, right? That one's excellent, so that one's less than 1 over 320, and this one is less than I can't even spell. That's not even the letter H, is it? It's the letter F. My handwriting's so bad I've forgotten what letter it is. And then this thing here is 1/2 of h of x naught minus f of x naught. That doesn't really help me though, does it? I don't know what that value is. Mat level maths, yeah. Well, for me, maximum doesn't mean anything about differentiation, really. For me, maximum means that there isn't a larger value. If you've ever heard of the triangle inequality, then please say. Yeah, okay. I'm suspicious. I think for time, I'm going to sneakily look at this mark scheme. Oh my goodness, what are we doing? That is what I've written down, isn't it? Oh no. Oh no. It's cleverer than I thought. Yeah, okay. It's cleverer than I thought. So currently I'm working with h of x minus f of x, and I'm getting all nervous because the right hand side's got this h of x naught, f of x naught thing that I don't know about. But actually, when I'm talking about the function being bounded, I just have to bound. Yeah, bother. How am I going to explain this? Yeah, now we're in a position where I've realized what I'm supposed to do and now have to explain it. Let's drop all the mod signs. I think everything's positive. Yeah, everything's positive, so chat will be happier if I just drop all of the mod signs. In particular, look, f is less than h, we're told, so h minus f is positive. So I'm just going to talk about whether h minus f is the kind of maximum value. The thing that I missed, the kind of trick that makes this simplify, is that actually I can do better than this. I can write out first that this is less than or equal to the maximum value of the function. That's an excellent. So there's x naught, f of x naught, which I don't know the value of that. That's sort of fine. There's going to be some algebra that happens. So first, instead of trying to talk about a general point, just talk about the maximum. Should have thought of that, but if I just talk about the maximum, like we were talking about the maximum just here in the previous part, maximum value. Okay, if I just do that, no, this is positive because again, f is less than h. Mara's being updated, reconnecting. That's positive, so I can drop the mod signs and just write down h of x naught minus f of x naught, which is going to be less than or equal to, on the right here, something that's at most 1 over 320, and 1/2 of the same object, h of x naught, f of x naught. That's really good because then I can do some algebra. If you've got thing is less than or equal to number plus half of itself, then you can rearrange the inequality. We call it a. A is less than or equal to number plus half of a. So half of a is less than or equal to number. Good. The triangle inequality is a thing about triangles, really. It says that if you've got two sides of a triangle, their total length is more than the length of the other side of the triangle. In terms of real numbers on the number line, if you add together two numbers, the absolute size of that is always less than or equal to the size of the sums of the sizes. I don't know why I said that out with words, that's not useful. So if a and b are both positive numbers, this is just obvious. If a is negative and b is positive, then you have to worry a little bit about how large this sum is. But the sum's not going to be as big as if they were both positive and you added them. So this is kind of the biggest that the sum could be. If they're both positive and then you added them, wow, that'd be enormous. So this says that when you add numbers together, the biggest that the size can be. Let's see if you added the sums. Chat is covering the screen again. It does that sometimes, doesn't it? We're going to go one more time. Myra's updated. Chat's back. Anonymous wants to know what happens if they link map to their GitHub in their personal statement. Probably don't click it. I know what GitHub is. I'm probably not going to click the link, partly because the formatting for personal statements doesn't include HTML markup, so I'd have to type it into my browser. Is it like 2021 question 5? Okay. Do you think first order logic is what maths actually is? I think it's what some maths is. I'm not convinced it's what all maths is. Anyway, right, good. Here we go. One last time. One last time. Myro's working. Chat's not on screen. I've worked out what's going on. Brilliant. So the question is about showing that this is a good approximation. F is a good approximation of H, which means that we need to think about the difference between H and F. The easiest thing to bound that by is just the maximum value. The maximum value of the function. We were talking about this in the previous part. I've just bound it by the maximum value. Now, of course, I don't know what that number is, but I do know some equations about that. I know that, for example, we know that h of x naught minus f of x naught is equal to g of x naught minus f of x naught plus the integral from naught to x naught of, oh my goodness, what a lot of stuff, h of t minus g of f of t, dt. And then we know some inequalities on these things. We know that this thing here is less than or equal to 1 over 320 because g is an excellent approximation to f by part 3. And we know that this thing here is less than or equal to 1/2 of h of x naught minus f of x naught. Okay, which again involves h of x naught and f of x naught. But here, look, the thing on the left is kind of the same as the thing on the right. So 1/2 of h of x naught minus f of x naught, if I subtract this from both sides of the inequality, gives me this sort of maths. Move this 1/2 thing over onto the left, which is good. 160 at the bottom. So, quick recap of what just happened in the last 10 minutes. I said a lot of nonsense about the triangle inequality and about mod signs. None of that was really important because everything in the question was positive, so I didn't need to write down so many mod signs at all. The idea that I was missing, so as well as using too much notation and worrying too much, the idea that I was missing was that you can bound a function by its maximum value. I should try and remember that a bit more. When I write down something like just check that this is bounded, I should immediately think bounded by its maximum. And instead of checking the whole range of values, to just check the value at the maximum. I think that's the hardest math question I've ever seen. Yeah, no, I think I'm going to put that on there. It's changed admissions. I'm the admissions coordinator. I coordinate everybody else's admissions officers around here for maths admissions. That's an overstatement. Oh, 2021 also had triangle inequalities, and I reminded you of them, which was mean of me because, as I've just admitted, not totally useful. Rowan says that they learned the triangle inequality, so that's good. Good. Cool. Okay. Wow. What a lot of stuff. It's 5 to 6, so somehow I'm still going. I think I've got to talk about 5 a little bit. These two are fine. If you're worried about this one, stick it in Desmos. This is really testing whether you know what x to the n looks like for different values of n. Does it look like this? Does it look like this? These are kind of large values of n pictures where I've exaggerated a bit. The different behaviors between like -1, 0, and 1 are all interesting. So whether or not you care about this question or getting the right answer or whatever, I'd encourage you to think about polynomials. These are called monomials, where instead of poly, several, just one, monomials. They don't get as much press coverage as polynomials, because polynomials, right, they've got all these coefficients and fun stuff going on. Monomials are ones where there's only one term. You should think about them. They're easy. They're simple. They like the numbers 1 and -1. yeah, I have a sketch in Desmos or something. And for J, I just want to show you really quickly this technique called compare the squares, where if you want to fight these numbers against each other to find out which one's larger, something that's easier to do is to do compare their squares. Also good for pizzas, right? Again, then you get kind of rational numbers sometimes. You know, if you do this cleverly, you get rational numbers. Rational numbers are easier to work with. You find out that this is 28 over 16 versus 25 over 16, so this one wins. Winner. I have to write verses because I want to write true things, and I don't know which way round, greater than or less than these are supposed to be. I've sometimes seen people write things like this, where they write like a both of them, and then go through and cross out the wrong one. I think that's a little bit messy. I don't mind being honest that we're doing a fight. Let's fight these ones as well. So here I'd probably subtract the third first. Maybe I shouldn't fight these ones. I'm looking for the largest, and this one's already lost a fight, but hey, let's fight them, why not? 15 take away 4 is 11 over 12, right? I think I've got that right. Have I got that right? It's kind of not important. 5 over 4 take away 1 over 3 is 15, take away 4 is 11 over 12. Yeah, don't doubt yourself. Okay, 11 over 4 versus root 6 if I multiply it by 3. What am I doing? Loads of stuff. 121 over 16 versus 6. 121 versus 96. Ah, cool, yeah, not even close. Winner. This one's too small. Smaller than 5 over 4. Almost bigger than 5 over 4. And then there's some maths to do to try and simplify these factorials. And there's some logarithms here. Love a good logarithm to try and simplify that. Yeah, monomials are examples of polynomials. Are basic polynomials. With one term. I'm off screen again on the bottom. I got just write down some numbers, 121 and 96. Bother. Yeah, I'm not doing a good job of staying on screen today. I have, because of the overlay, slightly more real estate than displays on here. To make space for the lovely URL, so that you always know where to find the MAT livestream. Very quick look at 5, just 2 minutes on 5. So I really think it might be easier to work with these things by just subtracting and adding numbers as you go along. So to just try and like write down the actual like things like this, and to give yourself a couple of lines to work it out. I see I've done minus wrong. Plus 0 is 2. Minus 0 is minus 1. Plus of 0 is 1. Minus plus of 0 is 0. So this bit is just like, why have they done that? That's just annoying. And now we've got these switching cases. There's one big S around the outside as well. We've got these switching cases, which I think I would just go in and think about really carefully. So here x is bigger than 0, so this is minus 2. Here x is bigger than 0, so I read this one. And here x is negative, so I read y, which is 1. And then finally x is negative, so I read the first thing, which is 2. There's like a big S around the outside. So I've done that super fast, but I think simplifying it line by line, rather than left to right or something, but just picking out which bits look easiest, which is kind of, instead of left to right, inside out. Computer scientists, depth first, breadth first, find out about those concepts. Here's a function, and it recurs. So it looks back at f of a, b minus 1. So it goes back to look at previous values of b. And it does that while doing some switching. So it switches eventually. If you get to a small enough value of b, then it switches to the other case and shouts a plus 1 instead. There's also this plus in here, means that this is, if I just tidy this up a little bit, this is s of b, a plus 1, f of stuff, plus 1. So I think this keeps adding 1 until b gets small enough, and then shouts a plus 1. So I think it does something like adding together a and b, maybe up to plus 1 or something. You know, how would I recommend learning about generating functions in chat? How good's the Wolfram Mathematica article? Let's find out. Nesting functions are good. I defined for all A, B, C, but the functions are written out by with x's. Oh! So they are. I wonder if that typo was in the actual test. Huh. Where's this paper? 2015. 8 years. Nobody has spotted this before. Possibly, or maybe no one's told me as well. Nav says, what are A, B, and C? Huh. I mean, in some sense it's fine. In a really stupid sense it's fine. Good. I think it's a sensible place to take a short break. If you've been looking at a screen, for the last hour, remember to look away from the screen briefly. Remember to be human. Humans need to survive. For me, that involves this cup of tea. It's kind of fine because whatever A, B, and C are, those functions are the same. It's a bit weird to say whatever A, B, and C are. They probably mean for all integers x, y, and z, right? You should define the range. Well, it doesn't matter, we're only feeding integers into them. Got away with that, I suppose. It's A, B, and C down here. It goes back to being A, B, and C down here, look. That's just A and B. X's and Y's. Huh. Yeah, so you can have okay, I'm not trying to defend it really, I'm just being silly. But you can have, for all A, f of x is equal to x, it is kind of fine, mathematically. It says you give me a value of A, and then I set the function to be f of x equals x, and I ignore your value of A. It's a bit like the constant function we were talking about before. I mean, not there, but the constant function kind of takes your input and ignores it. So how do you feel about for all x, f is equal to 1, right? It's kind of the constant function, right? And constant functions do count. There was something else in chat that I liked. Yeah, we were going to learn about generating functions. I was going to check if the Wolfgang Mathematica article was at all plausible. Right, so here's my attempt to find out about generating functions for you. I've got two options. I've got generating function. I've got some MIT notes. Send me the MIT notes. What I really want is the MathWorld thing, because the MathWorld articles tend to be a bit shorter. Okay, power series. Is this going to help us? Yeah, this has got some examples. Ooh. Yeah, that looks nice. Is this going to be useful? Is this going to tell me about probability and statistics? This looks a bit intense. Oh, this looks much better. Maybe. Yeah. Okay. No, this is good. So like the. Okay. If you want to generate the binomial coefficients, you just multiply out 1 plus x to the k. That's like a rule for relating some algebra to the coefficients. Yeah. Yeah. Okay. I'm going to recommend MIT. Math.mit.edu, but what I did was just Google generating function and then click on the first PDF that came up. That's what I would recommend. Somebody wants to choose a college. Choose a college. So you can choose colleges based on anything you like. Some people choose because they really like the atmosphere. They like the idea of studying there and living with other people in that kind of place. They all do the same maths, which is the thing that I really care about. Not Gauss has called me out for. Not Gauss found a typo, I think, recently in a different test. So there's now like dunking on typos. Here we go. Something said whole number when it wasn't a whole number. Good. Okay. I'm sorry we didn't do 6. I'm not a huge fan of this particular question 6. I think I might have got confused. So I've tried to do this question a few times before. I've realised that I'm not really comfortable with the idea of the word about. So if you've tried this question, you've got it at home. If you're happy with it, that's fine. If you're unhappy with it, that's also fine. I would move on and try a different question. There's some stuff about if Caesar is lying, then did Dieter say anything at all? That's a bit confusing to me. If Caesar's telling the truth, then fine, okay, Dieter did say something. If Caesar's lying, did Dieter say anything? And I think the answer is maybe, maybe not, which might mean we can't infer anything, because maybe Caesar's lying, but anyone could lie, right? Yeah, anyone can lie, so I think I can't really deduce anything. Maybe they're lying and everyone else is quiet. And then it kind of just doesn't matter. It's weird because then, from my point of view, they might be lying. And if they're lying, then nobody else said anything, so that's consistent, right? Because if nobody else is talking, then we can't deduce anything else. So I don't think I can deduce anything, which makes me very nervous about this. Yeah, we're dunking on typos now. We've made, what is this, like 3 in 20 years. Apply for the college with the highest acceptance rate for your course. That is hard to define. People get moved around. Yeah, people get moved around. It's coordination. People get moved around. Acceptance rate is really tricky because you need to decide if you're looking for the acceptance rate for people being accepted at that college or acceptance rate of people being accepted in general. And the first one tells you a bit about how oversubscribed that particular college was. And the second one tells you about the strength of the pool for the candidates at that college. Neither of which actually matters very much at all to you as an applicant. So I don't know. If you like, you can roll dice and choose at random. So in chat, Not Gauss says, considering all possibilities, C is telling truth or lie, so we can deduce that C is a vampire. I find that very surprising. I think it's possible that C is a werewolf. Maybe I'm wrong. Good day for me being wrong, right? I think Caesar could be a werewolf. And Dieter could be a very quiet vampire. And then Caesar is lying because Dieter didn't actually say anything. Dieter didn't say in particular it's a vampire or anything like that. Dieter would never say that, of course, because Dieter would be then talking about a vampire and Dieter would tell the truth. That would be nonsense. But Dieter doesn't say anything because Dieter's very quiet. There's like a language thing possibly. If you switch this for Dieter would say that. If it's like a hypothetical thing, I think I've kind of overthought the question and now I can't anymore underthink it. So approaching what we can infer from acceptance rates is the energy we need from that, right? I've got a logical question on the board. I've got a logical thing. I'm under chat once again. Dieter would say, yeah, David in chat agrees with me. And time lag means that I got to the punchline first, but then wrote it underneath chat. Underneath your very question. Right, good. If you visit a college that you like on an open day, but you really like that, can you put that down? Without a second one. Yeah, you only get to put one college down. You get to put one college down. If you're shortlisted, you get assigned a second college by an algorithm that lives on my computer. It doesn't take into consideration your preferences. It just assigns you a second college. Open applications is kind of the same. The algorithm gives you a first college. And then if you're shortlisted, the algorithm gives you a second college. Algorithms. Right, hang on, Knockout says, if C is telling the truth, then by the logic of I. Right. Yeah, okay, I agree that C is... Oh, can we infer... Okay, we can infer C as lying, sure, but that doesn't tell us anything about... Oh, okay. Is that what we're looking for? Just that Caesar is lying? But not whether Caesar is a vampire or werewolf or something? Is that what the question actually wants me to do? This feels kind of weak that I'm not deducing. Oh my goodness. Yeah, so the mark scheme seems pretty certain that Caesar is a vampire, and I don't get it. So I think I've come to terms. I've seen this question a few times before. I've come to terms with the fact that I do not understand this question. Good. What is my favourite function? Kind of like the Lambert W function, but we're not going to learn about that right now. Probably 2016. If both colleges offer you a place, so only one college can offer you a place. Your first college has priority. If they want to make you an offer, they win. Actually, I suppose if both colleges want to make you an offer, then the first college just wins the argument, and they're the ones who write to you with the offer. Good position to be in, but you do not get to choose. Oh yeah, sorry, that's the second half of your college. You know, James isn't lying. Yeah, I know. Maybe I was a vampire all along. If I was a vampire, would this count as a reflection? Can vampires do Teams calls? Are there any vampire live streamers? Or does this count as a mirror, right? So, yeah. Tara, you just choose one. For undergraduate applications, you just pick one. Graduates, still complicated and different. If you ever use the lambda W function, you just write your answer in terms of the double function. Yeah, you just write into the lambda W function. That's what it's for. It's for solving things you can't otherwise solve. So it's sort of like reducing other problems into this one semi-familiar problem, which then the answer is referred to as the lambda W function, which is this quite a nice combination of words and letters. Anyway, 2016 time. One of these is in the thumbnail, so we should probably do that one. I'm going to do democracy as well, though. I'm going to do the vote. The vote is currently on screen. And people are asking questions in chat, which I'll quickly talk about. So we started in questions early, but now we've overrun 6 o'clock. I don't know. I guess that means we've spent more time than ever before on a paper there. When you get assigned a college for more interviews, will you know what it is? Yeah, if you get interviews there, they'll write to you to tell you when the interviews are. Yeah, maybe this is just some sort of robot. Oh, film cameras have silver. Right, okay. David's got some vampire lore in chat, if you're in chat. Virtual images are fine, says Miles, so, yeah, no. The photons are being directed back at the herb because I've got a preview window on my monitor. I guess maybe those are different photons. Is that right? When does Oxford do offers? January. Any recommendation for other universities? Yeah, loads of UK universities are really good at maths and really good at teaching maths. Sometimes not. It's not okay for me to pick and choose and name other universities. It seems anti-competitive or something, I think. Yeah, have a look at other UK universities that teach maths. And at the moment for maths, we're shortlisting about 3 candidates for place at Oxford because somebody's in chat has asked. I can see chat voting for one I. Is that the thumbnail one? No, G is the thumbnail. So we're going to do I and G, definitely. Wait, are those the letters we did last time? Are you just voting for them? Did I reset the poll? I did reset the poll. When you find out you're shortlisted, just before interviews. It all happens quite quickly. MAT is in October. Shortlisting happens in November. We give people at least a week's notice. Interviews are in early December. If you put MAT to pending qualifications on UCAS, it doesn't mean anything. In my opinion, it's not a qualification. Other universities, I think, tell you to put it there, so carry on. But yeah, good. Okay. Okay. And in chat, we're trying to decide if vampires can see themselves in reflections or just silver. Silver's for werewolves as well, right? Silver bullets. Sorry, right, we're going way off track. Let's try and get back on track by doing questions G, I, and I can see a vote for J as well, which is not my favourite question to do, but let's give it a go. As we get some more recent questions, I've got more experience of doing them because I usually work backwards. This year I'm working forwards. So we're getting towards the questions that I've got more emotions about, I guess. There was a sequence a bit like this on the warm-up questions in the MAT Livestream, earlier episodes of this show, where you add together all previous values. So the thing to do when you see a new definition like this is to try and work with it a little bit. So you might work out, for example, that x1 is equal to, this thing means add together the sum, all of the terms from x0 up to x0. And that's just x0 then, so x1 is it's just that. X2 is a little bit more interesting because it says add up all the values from k as 0 up to 1, which is 1 plus 1, x0 plus x1, and 1 plus 1 is 2. Welcome to the Oxford MAT Livestream. So x2 is 2. And then x3 is going to be 1 plus 1 plus 2, which is 4. And at some point, you might start to spot some sort of pattern, which is that these things are 2 to the n plus 1 or something, or 2 to the n minus 1. So it looks like xn, except for the first one, xn is 2 to the n minus 1 upstairs, for n bigger than or equal to 1, I think. Yeah, sure. The first one's a bit different. It is the number 1. It's not the number. It's not the number 1/2. It's the number 1. But then after that, it looks like powers of 2. If you know about geometric series, which I think you probably do because it's one of the MAT flashcards, if you know about geometric series, you can prove that by thinking about the way that those sums actually work. You know that this bit of sum adds up to something very particular, number 7, but also you know that it adds up to something in terms of a geometric series, something to which adding 1 would really simplify matters. Okay, well, anyway, that aside, we're actually asked for this sum to do 1 over 1 plus 1 over 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus and so on, which is not a geometric series, but it's almost a geometric series. The stuff from here onwards is a geometric series, with first term 1 and common ratio 1/2. So this is going to sum to the number 2, and 1 over 1 is just number 1. So in total it's 3, 1 plus 2. I like this question because it's got two stages. One where you can kind of spot a geometric series, and then a second part where you need to spot another geometric series. It's a question with 2 geometric series in series. Gosh, I'm so sorry. Right, let's have a quick look back at chat to see what chat's doing. Chat's asking me about Warwick courses, which I don't think I can comment on. Some of my friends teach at Warwick, so if you're studying at Warwick, you'll be taught, in the current year, you will be taught by some people I know. So, I mean, does that mean I'm biased? Yeah, probably. Yeah, there we go. It's 3 on up in chat. There's a bit of chat about affirmative action in chat as well, which I didn't read out. And more chat about vampires and geometric series. So spooky all around. Okay. We don't have gender quotas. I would personally really like it if we have a closer to 50-50 gender balance between male and female students on the course. There are many reasons why we don't. And one of them is A-level classes, which is why the Oxford Maths Department is doing more work with younger people to try and promote mathematics. We do these events called It All Adds Up that are really good fun, with role model speakers and exciting maths activities and things. I think it would be illegal and a bit unfair for us to just do that at the end and just do some affirmative action on admissions. I think we've got more of a social responsibility, if anything, to do something a bit more wide and beneficial to society, which is why we're going wider and doing things with younger children who might or might not apply to Oxford. Right, cool. Let's do question 1i. It's a weird live stream. It's a mix of vampire science, me getting things wrong, typo bashing, and facts about admissions. Do I like the usage of the word fixed in proofs? Yeah, I think it's all right, isn't it? Has it hurt you recently? Miles says, haven't learnt geometric series. Miles, we have a live stream of that series a few weeks ago. If you want to learn, there's only about 4 things you need to know. You could learn them all in about 10 minutes. They're not hard. We did a worksheet and a live stream if you want to learn about those. Good. Right, okay, 1i. Chat's going away again to give me more space so that I don't accidentally write underneath the chat again. So This question is a geometry question in disguise. Let me show you why. This thing is definitely a circle, right? I mean, you can interpret it, if you're very algebraic, you can interpret it as just an equation that happens to be symmetric in x and y, but it's geometric, right? It's a circle. X squared plus y squared is less than or equal to 1. We're somewhere in this circle, or on the outside, I guess. And we want to make ax plus by really large, which means if I write ax plus by equals c, make c large, then, well, this is a line. Now, I don't yet know where the line is, but I do know that when I change c, that's going to change the line somehow. Maybe it rotates it, maybe it moves it sideways and up and down. I want to make c large. I can kind of see that if the line crosses the circle, then I could try changing c a bit and see if that changes the line a bit to move the line to other places. If the line's just going across the middle of the circle, then I'm probably missing a trick, because probably if I change c a little bit, the line will change, and there'll be other points in the circle that I could be using that give me a better value of c. In fact, I reckon the point's going to be somewhere on the outside, where I should make the line really extreme in some sense, so that I maximize c. That's the geometric strategy. Right, let's work out what the line is. We'll need some points on the line. So in particular, the line is not this. Gone. No. Gone. The line is not this. The line is something else. So points on the line, it goes through x. When x is 0, y is c over b. I regret my choices about where the axes are already. When x is 0, y is c over b. I'm finding the intercepts for this line. And when x is 0, when y is 0, x is c over a. Okay, so it's kind of a line like this. And I can see that if I make c larger, positive number, then the line will move away from the circle, like this. Because the intercepts will move. Let's try and match it up. Symmetry, there we go. If we make c larger, then the line will move so that the intercepts are further away from the origin, which moves over there. The gradient of the line is something to do with a and b. Let's work that out. So the gradient, this is a little bit of a silly way to do it, but I'm gonna go for it, which is the change in y divided by the change in x, which is minus a over b. Okay, I could probably have done something clever up here involving rearranging the line, but you know, swings and roundabouts get to the result. The gradient is minus a over b. Okay, so those are my geometric ideas, that I want to change this line to make c as large as it can be. The gradient's always the same, it's nothing to do with c. The gradient's always this. So really it's just like asking, how high can I make this line? Large c means moving the line, further away, and gradient's fixed, so it's just how far away can I go? I think it's probably clear now that the best I can do is if I have a line that just touches the circle at a single point. And there's some geometry to do. We're not done. The thing about interpreting the question geometrically, perhaps, is that we then have to actually do some geometry at some point, right? Probably. So here's the origin. Here's that point. I know the gradient. I know that radius and tangent are at right angles. So I've got loads of information to go and work out exactly where this point is. In particular, I know the gradient of this radius. It's a combination of phrases, right? Excellent. Gradient of the radius is b over a because there are right angles. So I want a point that is on the line this, y equals b over ax, and also on the circle x squared plus y squared equals 1. Go and solve that, rearrange, loads of stuff. I think it's the square rooty one. Can't quite remember. You can put QED at the end of your proofs. That's me. Oh yeah, so the B choice is a bit confusing, I suppose, because it's got the word max in it. I found out recently lots of people find this confusing, well, it just hasn't been defined at any point in the question or in their life. So that I'm teaching you something, this is defined to be, it takes the maximum, that's the maximum. It takes the value a, if that's the biggest, it's greedy. But if not, if a is smaller than b, it'll take b instead. If they're equal, then it doesn't matter. But if they're equal, you could say it's taking A. There's a similar idea, min of A and B, which you should go and try and work out how to present that so that it does the minimum. You should work out the cases at home. Yeah, I found out semi-recently that this is not favourite. Good. What's my favourite proof by method? Probably contradiction at the moment. No. Yeah. I should get a guess. How do you think to set it equal to C? The thing we're trying to maximise. Yeah, so is this the same lesson that I had before, right? If we're trying to maximise it, try setting it right equal to value. Yeah, this is the same lesson we had before, I think. We had something with H's and F's, and maximising it, I had to write down it's less than or equal to its maximum value. The concept of its maximum value as a thing that you should write down, that was my weakness in the F and G and H kind of good, excellent approximation question, this time about an hour ago. Here, I don't know how I thought of it faster this time, but I guess I was thinking geometrically, and I was thinking about lines, and it's not a line when it's just an expression. It needs to be equal to something. So I'm just giving it a name. Giving things names is powerful. Thinking about the actual maximum value of a thing turns out to be a good way to think. Yes, good. Okay. The reason why I was thinking about doing things, variables, constant. Oh my goodness. Okay. Mathematical difference between variables and constants. Yeah. Okay. Oh, so they use the word fix, like let x be a fixed number. Now double it. Yeah. Okay. Oh, so can you get through this question? Not Gauss in chat has got a suggestion for getting through this. If A equals B equals 1, does that help you? So an even cheekier suggestion might be A equals 1, B equals infinity, or something mad, in which case. So the question's got A and B positive real numbers in it, which we could set to be anything, just to kind of check our answer, right? So we could say x equals 1, b equals like 10 to the 10, in which case clearly the largest value would be about 10 to the 10, because I'm going to put all my eggs in this basket, the by basket. Chat's still on. I'm going to put all my eggs in this by basket, so that I get this huge value. And then which of these are equal to 10 to the 10? Oh, that one is roughly. That one is not. That one is roughly. That one is roughly. And that one is not. So that kind of gets you down to 3 options if you just think about different cases. They're all symmetric, so there's no point trying the other one. Should I try A equals 1, B equals 0? Oh, I guess they say positive real numbers, not putting another 1 or something. Maybe that gives away something else. That's about making x really large. Yeah, this is fun. Okay. No, it's the ratio that matters, so this is pretty much the same case. Anyway, good, right. Strategies. If you're told something is true for lots of different values, try plugging in some values. Here, we're not quite told a thing for lots of different values, but by the time we've done the question, we will have something that's true for lots of different values. Okay, J, because it's right here. Here's a better answer for the person who asked me about if and only if stuff. This question doesn't use the phrase if and only if, but it is about that sort of logic. So, for example, it says here, if pi of n equals 1, then there are values of xn which are impossible, which is that way round rather than the other way round. And so it doesn't say if there are values of xn which are impossible, then pi of n is exactly 1. The things I don't love about this question, it uses capital Pi, which I sort of know why they've done that, but still, it's hard to pronounce in your head, right? When you're reading it to yourself, it's hard to pronounce it if you've never seen that letter before. Advantage to people who speak Greek. the other reason is that the wording is quite hard to follow. Anyway, let's think about what it means to be for pi n to be equal to 1. That means that the number of distinct prime factors is 1. So it's p to the a for some prime p, if then, and integer, I guess positive integer, a. Oh goodness, and there's some values of xn is the last digit, so some values of xn that mean that n cannot be prime. Oh my goodness. I think most of these statements are true, and we're not really required to prove them, so some values cannot and must. They're not quite opposites, right? Just shout pi in your head. They've used pi because it's, I don't know. I thought because it was, yeah, because of the first letter of prime is p. And it reminds me of, yeah, I'm thinking of something different. But it reminds me of some other things I've seen that use Greek letters and talk about prime numbers. I'm thinking of all this totient function, which is not relevant right now. And that's twice in one live stream that I've been thinking about something that's not relevant. Try find some counterexamples. Yeah, I agree. How much do I want to do this question? Not very much. D just looks true, right? D looks extremely true. I've never seen a more convincing conclusion than we cannot tell if n is prime. If we could tell if n was prime, then that would be great. Right, let's try and find some examples to demonstrate that we cannot tell. What's the value when n is 1? So n is 1, that would give me pi n. I don't know how many distinct. Oh, n's bigger than 1. Great, cool. N is 11. That's got one distinct factor and ends in 1, so that's an example. N is 21. No, I need a power because I probably want this to be 1. A power like 81. Yeah, good. Okay, 81 has got pi of n 1 because it's just a pure power, but the last digit is 1, so it's got pi of n plus x of n is 2. So we cannot tell if n is prime. Brilliant. Okay, that sort of thing, 4 or 5 times to say, oh yeah, we cannot tell if n is prime because it could be 11 or 81. Finding examples or counterexamples along the way. If pi of n is 2, all values of xn are possible. If the last digit is 2, no, if the, oh gosh, okay, if the number of distinct prime factors is 2, then all values of xn are possible. That just sounds true. Because, I mean, what do we mean by all values of xn, by the way? All the values that xn could take, it does take. Doesn't quite, anyway, never mind. All values of xn, so I think they mean 0, 1, 2, up to 9 are all possible. And that just feels true because I can think of composite numbers that do this, like 10 is 2 times 5, 21 is 3 times 7, 22 is 2 times 11, 26 is 2 times 13, I'll need that in a minute. 34 is 2 times 17, you know, stuff like that. So I think it's just fine. What about xn equals 4? 34. Is it we can't tell? Yeah, we can't tell. Oh, 11 times something would be clever. Yeah, well done, chat. Anonymous person in chat. Someone in the chat says they haven't got an email, Desiderius. Could be the case that your email, 2 things. One, your email might have been typed incorrectly, and the email might have been sent to an email address that doesn't exist. Or 2, the email might have gone to you but been blocked by a firewall, gone to spam, gone to junk. Those are the 2 ways to solve the problem of the missing email. Either it was never sent to you, or if it was, it got intercepted by some sort of software thing. How much better can you get at MAT in a month? Quite a bit, I think. And I assume you mean how much better you can get at maths. I think I've got better at MAT in the last month. I think I'm going to get better at MAT in the next month. It's that time of year where I get good at MAT questions. Hasn't quite happened yet, but I'm not worried. Good, okay. I've forgotten which questions I was supposed to do, so I'm going to quickly look at the poll. What are we doing? We've done, somehow, 2.5 short questions already. And I'm looking at chat. Chat wanted me to do 5 and F. Let's have a look at F because it's nearby. Oh yeah, cool. If you're stuck on F, try this. Let U be x squared. Sub in U for x squared, and then talk about that polynomial. It's the factor theorem, right? The factor theorem tells you something about the relationship between factors and plugging in values. So if we could factorize this in terms of x squared, then we'd be able to factorize it. This question causes issues because x squared plus 1 itself doesn't have any factors for real numbers. So we're looking for factors that sort of don't exist. We're looking for a quadratic factor, not a linear one, and you only know the factor theorem really for linear terms. But yeah, try u equals x squared and then try and think about the polynomial in terms of u. Let's have a look at 5. Oh, 5 is a good question. Someone says, didn't realise we should be checking an email. Depends whether your test centre has registered you yet or not. They've got a couple of weeks. They might not have done it yet. What email addresses will our MAT logins come from? I think either at admissionstesting.com, I want to say. Admissionstesting.com. What did we register? Admissionstesting.ox.ac.uk, sorry, not .com, or from tcs.com. Yeah, so Anonymous in chat said they subbed in I and it worked nicely because they're using complex numbers. I personally think that it's better if the questions don't use complex numbers. Uncontroversial. And I also think it's better if you don't do the questions with complex numbers. But you can't do the questions with complex numbers, I suppose. Turns out it's extremely difficult to write questions to which nobody will use complex numbers because people love using complex numbers. If they know about complex numbers, people love using complex numbers. See if you can work out how to use complex numbers on this question. Actually, the factor theorem kind of works slightly differently for factorizing polynomials is a fascinating thing in general. Anyway, let's do this question. We're given this sum, which is not a geometric sum or an arithmetic sum. It's just some numbers. But there is a rule for those numbers, I suppose. They're n times 2 to the n. So this is 1 times 2 to the 1, plus 2 times 2 to the 2, plus 3 times 2 cubed. I like to write out the terms a bit when I see something like this, so that I can check that, check where we're starting and check how it matches up with, 3 times 8 really is 24. Good. Okay. Part I, given that it's an plus b times 2 to the n plus c for some constants, set n is 1, 2, 3. Okay, brilliant. That tells us how to do the question. Find 3 equations and then solve them. Okay, fantastic. Clear what we're going to try and do. We're going to try and show that this is equal to some really nice expression. A bit like how you know an expression for geometric sums, apparently there's just some expression that this sum is equal to as well. And if we believe that, then fine, we can work out the values of a, b, and c. Okay, the structure of the question is we're then going to show that if we add on one more term, so if we add on one more term, then it works, that the next thing works as well. That it's true even if we add an extra term on. We update what the formula says and we update the sum, and those things change in the same way. And then we're going to assume that it's just true. So now we know this fact, and we're going to simplify some expressions, use it in things, before finally, as a final show, adding some things together at the end. Just to mix things up for the live stream, I'm going to do the question backwards. You do the question forwards, I'll do it backwards, and I'll see you in the middle. We haven't done question 4 yet. It's blank paper for the answer sheet. I mean, not totally blank. There's bits at the top for test reasons, but the answer booklet is blank paper. Right, I'm doing the question backwards because I think that sounds fun. So by the time we get down to part 5, we know that the sum is of this format. well, by this point we've proved something amazing. We've proved that the sum of n2 to the n from n is, oh gosh, n is 1. Regrets. By this point we've proved something amazing. We've proved that the sum of from k is 1 to n of k2 to the k is equal to a n plus b 2 to the n plus c. And we've worked out what the numbers a, b and c are by that point in the question. I haven't done that. I'm doing the question backwards. So what I'm going to do is try and work out this sum just using these facts. You know, just see what happens. So I want to multiply this out, I think, because I've noticed that this n2 to the n, whoops, I definitely mean k here as well, don't I? Yep, sk, so k. I've noticed that this k2 to the k is exactly the same as this k to the 2 to the k. So I guess I want to write it out like this. With these kind of separate terms. There's an a term, there's a b term, and there's a c term. But the c term is easy. The c term, all of this is being added. The c is just adding c each time, and there are n terms, so it's just n lots of c on the end. This term in the middle, this sum in the middle is geometric, right? So that's 2 to the n plus 1 minus 1. There's a b on the front. And this term over here is asn. It's the sum that we had before. So I should plug this in, right? Which is, I've got a formula for this. So by the time we get down here in the question, we're just using the facts that we had before. We need to know the values of a, b, and c, and hey, maybe this simplifies or something. But it looks pretty much like we'll just be off and away by that point. Okay, let's read upwards in the question. By the way, if you just do this in the test, if you just go down to the bottom part and have a go at trying some things, then you can get marks for that. You can get marks for working things out, even if you've skipped the previous parts. It's not lined paper. The matters, as far as I know, never used lined paper. Give you freedom of space. Like this, right? Which is a big gap. 70 is a good score on the maths, I think. There's no score which guarantees you an interview. It's not hard cut off. It's not pass fail. 70 was a good score this year as well, I think, in 2016. It doesn't matter what order you do the parts in. I'd like it if people labelled things. So here it'd be nice if I'm doing this on a bit of paper or something. It'd be nice to like label, or to just put like, just so you know, I'm doing this question backwards. You can't stop me. You know, if you communicate that, then it's, well, if nothing else, it's a bit fun, isn't it? Right, let's look at these ones as well. What have we got? So this un, I'll do the question backwards. 1/2 plus 2/4, that's another half, plus 3/8. Okay, so I can see 1, 2, 3, n at the top, and 2's downstairs. And this looks a bit like Sn, but divided. Oh no, the different terms have been divided by different amounts. So that's rubbish. Is it something to do with Tn? N, and there's an n over here, it's been divided by 2 to the n. There's an n minus 1 that's been divided by, there's an n minus 1 that's been divided by 2 to the n. Because the term they didn't show me here, but the term before here would be n minus 1 over 2 to the n minus 1, which is this thing divided by 2 to the n, right, okay. And then all the way down to this thing divided by 2 to the n gives me the 1/2. Right, so they've shown me these terms line up with terms hidden in the ... and these terms line up with terms hidden in that ... So this is just Tn divided by 2 to the n, with the terms written backwards and divided by 2 to the n. Okay, fine. Tn, working backwards. Tn is, oh my goodness, is it something to do with Sn? I'm hoping that I can just reuse previous parts of the question, right, as I work backwards. What have I got? I've got numbers counting down multiplied by powers of 2, but in here they counted upwards. So what's the difference there? The difference is, I suppose, loads of multiples of 2. No, where's 2? That's n 2 to the n take away 1 for the difference, and then hiding in here, n minus 1, 2 to the n minus 1. So the difference would be 2 to the n minus 1 minus 2, and then 2 to the n, so there's a difference of powers of 2, and I could pull those together and do a geometric series. Yeah, sounds right. Okay, so it's something to do with Sn. Is there a different way to do that? You pull out all the n's, and then, yeah, hiding. So negative 2, negative 8, negative 24. There's your SN. Right, cool. Okay, so you take the negative parts of each term. Those spell out negative SN, and the positive parts with these n's in, those are a geometric series multiplied by n. So do a geometric series, do some minus Sn on the end, write out your formula for Sn. That's what's going on with Tn. Okay, part 3, using these values, show that if Sk is equal to Fk, so if 2 plus 8 plus dot 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 plus k2 to the k is equal to ak plus b 2 to the k plus c, then, well, so Sk plus 1 would be 2 plus k2 to the k plus another k plus 1 2 to the k plus 1, which would be, oh my goodness, so this would be, because this thing, we've got a formula for it, that's Sk, and then we also have this k plus 1 2 to the k plus 1, which would be, what have I got? Loads of stuff times 2 to the k plus 1 and a c on the end. So the c matches with what I was expecting. So this thing here, a f of k plus 1, the thing I'm looking for is this 2 to the k plus 1 plus c. So I suppose I better hope that, okay, matches if a k plus b plus 1, ak plus k plus 1 is equal to ak plus a plus b, which I suppose only works out if a is equal to k plus 1. That is not true at all. I've done something wrong. What have I done wrong? Okay, I failed to match up some terms, but that's okay. We can fix this. Fixing work is important. Oh, I missed a factor of 2. Yeah, well, that sounds crucial actually. There's a factor of 2 in here because this has got extra 2's on it. Actually, I want to divide by 2. Yeah, I want to divide by 2, don't I? So ak plus b. This matches up to high. There's k plus 1 up here. Is equal plus k plus 1 is equal to ak plus, oh my goodness, a plus b. Not obvious to me if that's true or not. I think it's no longer obviously not true. It looks like I would need a to be the number 2 and b to be minus a half or something, or minus 2. Let's find out if that's true by working backwards to part 2. Looks like it's only true for certain values of a and b. Don't know about c, but c seems to be fine. C is pretty chill, so you just hang that on the end. Solve the equation for part 1. Right, now I'm stuck. Now I cannot work backwards, right? So there's a limit to how much one can work backwards in a question, especially if it says solve the previous part you had. So lost watching this backwards. Good news, real format, we're now doing the question forwards. Okay, I wanted to show you the ideas at the end of the question and also mix it up a little bit because I've been live for an hour and a half. So we're going to say n is 1, 2 and 3, which gives us not the first 3 terms of the series. Setting m1 to 1, 2 and 3 gives us the sum up to the first, the second and the third terms. So it gives us 2, 2 plus 8 and 2 plus 8 plus 24. Very common mistake I've seen when doing this question with other people before is that they'll just write down 2, 8 and 24. But those are not the values of the sums, those are the terms in the sum. It's wicked, it looks like a sequence, it's written out like a sequence, but Sn is not the sequence, it's the sum. Okay, which is a bit annoying really, because if you write down the wrong numbers here, you get the wrong numbers over here, and then everything kind of crashes somewhere in the middle. Okay, so if I plug in n equals 1 over here, then I'll get something like this. If I plug in n equals 2, then I'll get something like this. If I plug in n equals 3, then I'll get something like this. Those are my equations. And then I'm supposed to solve them, which I think involves doing, well, I kind of want to do differences of equations, right? Take some differences. So you take differences of the first 2 is one way to cancel out the c's. I need to get rid of the c's. The c's look easy to deal with later. If I do the difference of these 2, I'll get 8 is equal to well, 6a and 2b. And if I do the difference of these 2, then I'll get 24 is equal to 24 A's here and 8 A's here, so 16 A's plus 8 B's and 4, take away 4 B's is 4 B's. And then I can see that what I really want to do now is double the first one and take it away. To get 4A is 8, which gives me that A really is 1/2, which is I think what I wanted it to be. Maybe I wanted it to be the number 2. I did, and it is. I can't solve the equation at the end. Oh, I was so pleased with myself for doing the simultaneous equations really fast, and then I divide it by 4 incorrectly. It's going to be one of those days. What's B at the end of that? 32, you need to take away 2, lots of 4 to get down to 24, right? 12, take away. You can see that message though. So you couldn't see the one saying that I was disconnected. You can see the one saying that reconnection is successful. Right. Speed challenge, you want to do a factorization. Is it the difference of 2 squares? If it's the difference of 2 squares, you can win some biscuits. Speed challenge, let me write it out. 101AB minus 10A squared minus 10 squared. I'm a bit suspicious there's no B. Did you mean a B squared here? Can I put a B squared here? Don't like the way it's not quadratic. It's making me nervous. I can't factorize it. It depends on B. B squared. Oh yes, B squared. Right, okay. A speed challenge with a typo. It's worse than doing a math question with a typo. Wait, is it difference of 2 squares because it's... I'm rubbish at this. Oh, this is really embarrassing. Why would I try and factorize this? What am I missing? Wait, that's 100 AB plus another AB? No, that's one of the silliest things I've ever said. I could factorize it if it was 200. Don't know, don't like it. Why am I so slow? It's just the quadratic formula, right? It's just the roots. Divide by b squared, and that's roots. I've been set a maths problem in chat. It's not going very well for me, but that's okay. There's minus signs all over the place as well. I genuinely don't believe that that's good. Not the silliest thing I've ever said. I have said some pretty silly things. Is it 10 and 0.1? Yeah, 10 and 0.1. Good, okay. A over B is 10, or A over B is 0.1. Okay, I don't think I did that particularly fast. But, so my solutions are, A is, yeah, okay, so if I multiply that up, yeah, I don't really feel like I've done anything clever here. Some root 10s, probably. 10A take away, let's write that one as 10A take away B. A take away 10B? No, that's nonsense. Yeah? No. That gives me 10A squared, 10B squared, and 101 ABs and the minus sign at the front. Good, did it. Well done, but negative. There we go, good, finally. Okay. I don't think that was very fast. Speed challenge. They said speed challenge, and they gave me a problem that I did quite slowly. Right, cool. It's been a day for me making mistakes, messing things up. We've not talked about question 4 yet. Question 4 is pretty good. I'm not sure people voted for it, but the setup for question 4 is you have these circles that are tangent to each other and to the lines. I think there are at least 2 of them. And the trick of the question is that there's secretly a geometric series. Let's try that one more time. There's some similar triangles hiding in here. It's optional to use the similar triangles, but I think the question is much nicer if you identify some similar triangles, right? So here are the similar triangles, the 2 that I've just drawn. And once you've worked out that they're similar, then a lot of the things that you're being asked about, so the fact that their radii are 1 and 3, this is the case where they just touch each other in part 3, 1 and 3. So you've got this fact about the similar triangles, which just makes things a lot nicer. You also know that this is 1 and this is 3, so this is the number 4, at which point things really start to fall apart, I think. Do some angles. I liked that factorization question actually in the end. I think I did it in quite a messy, not very nice way, where I should have just stared at it and said the thing. For question 4, part 4, I said, if you change units such that 3 is 1, brilliant, you've invented something a bit like the James-ometer that I invented a few weeks ago for a geometry question. if you change units such that 3 is 1 unit, then CT now has radius 1, and the next one has radius 9. So for C, I think if I was marking this, if I was writing the mark scheme as lead examiner or whatever, I would accept any argument that pointed out that it's a geometric series. It's a geometric series for a nice reason. It's a geometric series because it's a geometry problem that has rescaling in it. The kind of quick way to get to 9 is to just rescale the initial problem with these 2 tangent circles. Which for that value of alpha, touching circles have the larger one 3 times as wide as the smaller one. And that'll be true for this pair as well. Replace 1 to 3. MAT happens at 9 AM British time in most time zones. There's information on the tests website on the ox.uk/tests page. There is info out there on different countries, different time zones. But we try to start it, at least I think this is the plan, we try to start it simultaneously for everyone, more or less. There are some regions where that would be mad. Suggestion for Paris 24. Bit short notice for Paris 24, right? I guess they don't need to build a very big arena for speed factorizing. We'll see. Okay. Drew a graph for a question. We draw more stuff on it later, even if the question doesn't ask for it. Yeah, sure. Some poor person who's marking it is going to be looking for, like, if it says show the turning point and you've labelled so much extra stuff that no one can read your turning point anymore, then you've kind of made it harder for us, right? But you can mark extra things on. It's fine. And there's this area part at the end of question 4, which I think I like. The best way to approach this area here is to do area of, I want to say trapezium, but you can think of that as rectangle plus triangle, minus bit of a circle, minus another bit of a circle. So rectangle plus triangle minus wedge of a circle minus wedge of a bigger circle. Those are all kind of building blocks that you can work with. All the angles are quite nice at this point. So being able to work with these sort of things is not too bad at all. I can't remember any of the widths or heights of any of these things. Is that 1 over there? Yeah, cool. So I kind of need this width as well, I think, in order to work out how big my triangle is. Miles knows someone who can factorize cubics just by looking at them. Funny. They've possibly learnt the cubic formula and we should be scared of them. Good. I've got a favourite cubic at the moment, but the problem is the cubic is the punchline to a question. So you do this question and then the answer turns out to be this cubic. I showed it to some people earlier this week, so I can't just tell you the cubic, I've got to tell you the question. Good, okay, what did people vote for? I think we got 2 minutes. 2 minutes and people voted for I and J and then I did neither of them. Oh no, I did both of them on this one, and 5, and F. We talked a tiny bit about F. So for F, the idea when it settles down is that try u equals -1 to find out if u plus 1 is a factor. And if you try u equals -1, that's still squared, so this is 4 to the n. These ones are just numbers. And this thing is only going to work out, this is only going to be 0 if and only if, to use a phrase. Sorry to the person who wanted to know about if and only if. Look, here I go. This is 0 if and only if n is even. So here it's a shorthand for talking about odd numbers as well, but kind of subtweeting odd numbers by making a statement that's about odd numbers without saying odd. It says if and only if, the kind of only if is carrying some weight there. Good. Okay. 2 and 3 did get some votes too on that poll. I haven't talked about 2 and 3. I'm going to look at them really quickly. It is 7 o'clock. This repeated function iteration, I think we talked about this one possibly last year on the live stream, or I feel like I've talked about it recently in my life. There are several methods for the last part, including multiples of 6, which is just a brilliant idea that I wouldn't have thought of. remember, so the key for this is to show at the front, you show that A and B, you can switch them around. And then later on, that becomes really important because these kind of like different orders of A and B, this shows you that all the different orders are equal to each other. So shuffling things around is allowed. Oh, there's voting going on, right? Okay. Less voting. Good. Rearrange to give the all end works. Does it? No, because these -1s, right? I'm going to check my answer to that because I'm being challenged in chat. Yeah. You need to. So if you've got an odd number of ends, then you'll get odd number of minus signs here and an extra one. Now you're adding together 4 to the ends. So you get something massive, like 2 times 4 to the n. I almost said 8 to the n, which would be another mistake for today. Someone did multiples of 6, question 2. Very quick look at question 3. Question 3 is about reflections in the line x equals alpha. We talked about these a couple of weeks ago. I'm not sure, but there's some polynomials. Look, here, look. Polynomials being built out of monomials. Look how they grow up. Oh. This question's giving some respect to monomials, which is good. Good. There is 7 parts to this question, which is quite a lot, and some sort of symmetry arguments for the thing. Yeah, the word there in chat is commute. Oh, it's not in chat. Why is it not in chat? There it is. A and B. Commute for when you can switch around the order. Technical term. Although I think it's a technical term that some people are now learning very young. I was once talking to a 6-year-old trying to explain that 3 times 4 is the same as 4 times 3, and the 6-year-old said, yes, multiplication is commutative. And I thought, what are they teaching the 6-year-olds these days? Multiplication is commutative, apparently. In a maths computer science interview, I'm not sure if you would see mechanics questions. I suppose no reason why not, but well, some reason why not. You're not going to do any mechanics on the course. That's probably a good enough reason not to expect a mechanics question in your interview. Is binatural real time? I'm not sure it is. I'm going to quickly Google it. We're slightly over. It means two-faced, right? It means two-sided. I think it's not a maths thing. I'm prepared to be wrong. Oh, no, yeah, it's a real thing. Mirror image. Yeah, cool. Okay, real thing. I am wrong. There you go. Just one last chance. One last chance. Still have a chance of getting a day like today for James. Wow, is it that bad? I did divide by 4 incorrectly. I think it's going to be one of those all-timers, I think. Never say never. Never say 2. Right, good. Sometimes say 1/2 for the value of 8 divided by 4. Chat's been really fun. I haven't had a great day somehow, but maybe you have. I'll see you next week for, oh my goodness, 2 more past papers in 166 hours for another episode of the MAT Livestream. Have a good evening, have a good week, and may your division always give you the answer the right way up. Bye.